Hello everyone, welcome back to my channel. So today we will discuss about the third module of the control engineering subject, which is the 7th sem subject. So as far as VTU examination, it is the most important module as there are certain problems of the block diagrams, as the chapter indicates that chapter name is block diagram reduction and signal flow graphs. You have to reduce some block diagrams. So first of all, we should be knowing that why we need to draw the block diagrams, right? So there are a lot of hectic systems, my dear friends, which are very difficult to understand very keenly. So we have to reduce it in the form of a block diagram so that we can analyze the system very well over there, right? So if I take the VTU paper for the sake of an instance so that you will be understanding clearly. So this is the question over here: reduce the block diagram as shown in figure to simple form and find transfer function. So if you are observing here, it is a complex system over here which you cannot easily analyze. So for that purpose we have to reduce it in the form of a block diagram. Okay, so first of all, let's see what does the block diagram mean over here. It is simply the pictorial representation of a what we call as complex system, so that we will easily understand this. So it consists of one forward path block and one feedback path, right? So these are the two what we call as blocks in this particular diagram over here, which you have to which you have to remember in this case, right? So the problem you have to reduce only in this particular form. There should be at last only one block in the forward path and only one block in the feedback path, right? So this one is the input, which is represented by the R of S, or you can easily tell this what we call as denotation as summing point, and this is called as takeoff point. It is nothing but output. Okay, so this is all about the block diagram. Okay, then we should understand what does the transfer function mean. So and finally in the question they will be giving find transfer function. So all the question is based on this particular transfer function. So let us understand first what does this transfer function mean. Okay, so transfer function, so my dear friends, it is nothing but it's a mathematical function which gives us the effect of system parameters on the input, what we call is to observe the or to get the desired output in this particular diagram. Okay, so it is a mathematical function. We can write it in the mathematical format as transfer function is equal to output upon input. So with respect to input, how the output changes, so that is called the transfer function. If I say in this in simple terms, so transfer function is nothing but output upon input. So how input is changing to get the desired output over there. So this is the transfer function over there. So there is a formula for this. Let us derive first the what we call as equation for this transfer function. Okay, so let us take the system same here. This is your summing point. Okay, this is your forward path block G of S, and then is takeoff point C of S, and next one is the feedback point, right? So this is your H of S, your feedback point over here. So this is positive, negative. Let us talk later on it what are these operations plus minus over here. So first of all, if there exists an error signal between summing point and the forward path block error signal, and if there exists a what we call as another function, that is Laplace function B of S, in between the summing point and feedback point. So first of all, let me tell you what is this R of S, B of S, E of S. Let us denote it. Okay, R of S is equal to Laplace of reference input. Okay, reference input, and next one is E of S. It is nothing but Laplace of error signal. Okay, this is the mathematical function error signal. Okay, next one is B of S, which is equal to the Laplace of feedback signal. Okay, is it okay? Then next C of S, it is nothing but Laplace of desired output. Okay, next one is G of S. It is nothing but equivalent forward path transfer function. Then next one is this H of S. Okay, so this is h of s is equal to equivalent feedback path transfer function. Okay, these are the denotations which we use in the block diagram to get the transfer function. So if I derive the equation for this transfer function, let's observe over here. I can write from this diagram itself. If you just observe, I can write E of s, that is error signal. It is nothing but addition of these R of s and B of s. Okay, that is, I can write R of s plus minus. I can write, just because there are two operations plus and minus, that is positive feedback and negative feedback. Okay, so this I can write plus minus, this is bs. Okay, so it is nothing but addition and subtraction of R of s and B of s. R of s and B of s, I can write E of s is equal to these two. Okay, next one, if I just call it one first equation, then next one is B of s. If you just observe B of s, it is nothing but the multiplication of H of s and C of s. You just see here, it is connected to the CS over here. So I can write it is the multiplication of H of s into C of s over here. Okay, this I call the second equation, right? Next one is I can write over here C of s is equal to, C of s is nothing but, this is output, so this is connected to G of s and E of s. It is nothing but multiplication of E of s into G of s over here. So I can call it third equation. Now simply substitute second equation, substitute equation second in equation first. This you have to put the value of bs, you have to put in the first equation, b of s, right? So I can write E of s is equal to R of s plus minus, instead of bs I have to write this value, that is H of s into C of s over here, right? This I call as fourth equation. Now from third equation I can write, from equation third, you just observe over here, from equation third I can write es is equal to C of s. When I transfer this G of s to the left hand side, so it will get divide C of s upon G of s. Now I call it fifth equation. Now you observe fourth and fifth equation, E of s on the left hand side, E of s in the left hand side. So both left hand sides are equal, so I can easily write the right hand sides are also equal. So I can write from fourth and fifth equation, equating fourth and fifth equation, right? So I can write C of s upon G of s is equal to this term, R of s plus minus H of s into C of s over here. Okay, I hope you are getting my points over here. The next thing is I will just multiply this G of s to the right hand side. Okay, this is the simplification, only simplification you will do it. So C of s is equal to R of s into G of s, okay, plus minus G of s into H of s, into H of s into C of s over here, right? Now I can write C of s, okay, then plus minus this G of s I will just take on the left hand side, so it will be C of s plus minus G of s into H of s into C of s. Okay, so which is equal to R of s into G of s. Okay, if I will take cs as common in this term, okay, I can easily take C of s common in this particular term. I will get 1 plus minus G of s into H of s over here, okay, which is equal to R of s into G of s over here, like right? Then I can write C of s upon this R of s. If I just transfer in the left hand side, I will get C of s upon R of s is equal to G of s upon this 1 plus minus G of s into H of s. Okay, so this is your transfer function. Transfer function is always equal to C of s upon R of s, that is output upon input, which is given by the G of s 1 plus minus G of s into H of s over here. So this is your transfer function. Now the question is, what are these plus minus values? Okay, so these positive positive and negative value. These are the most important ones, so you have to make a note over here. So one note you have to make over here. So if the value is positive, positive is the feedback over there, so positive is used if feedback is negative. If your feedback value is negative, in the diagram itself you can easily observe, suppose this is the negative feedback over here, this is called the feedback path, this is called the forward path. Okay, so if feedback is negative, then you have to use positive value in the formula, g of s upon 1 plus g of s into h of s. If negative is used if feedback is positive. If you are suppose a feedback is positive, then you can just take positive value over here. If positive is positive is used if feedback value is negative, and negative is used if feedback is positive over here. These are the two notes which you should remember. And this whole transfer function c of s upon r of s is equal to g of s upon 1 plus minus g of s into h of s. It will be used in the whole module and whole problems. You will use this particular formula in the reduction of these block diagrams over here. In the Vtu examination, these will be the definite questions. These block reductions, obtain transfer function of block diagram shown in figure by reduction technique. So these are the important questions which you should remember. So in the next video we'll just solve one problem from this reduction technique. So thanks for watching my video.